It started. All right. So this unit is on rational expressions. The word rational in math means fraction. Rational numbers are numbers that can be written as a fraction. Rational expressions are expressions that are written as fractions. So what we are doing in this unit is we are dealing with all the fractions, all units. Fractions, fractions, fractions. All right? Now, simplifying a rational expression is important because at the end of every problem, you are expected to simplify your answer. So if I have one fraction added to another fraction, I'm going to go through the process of adding, then I'm going to simplify. If I'm subtracting fractions, I'm going to subtract, then I'm going to simplify. If I multiply, I'm going to simplify. If I divide, I'm going to simplify. So this day is important because we're going to do simplifying after every single exercise that we do. Does that make sense? Why it's important? Okay. This is going to kind of be your cheat sheet. Hey ladies, we got to be listening. This is going to be your cheat sheet for the unit. So anytime you get to the point where you are ready to simplify, you are going to walk yourself through these 5 steps to make sure you have simplified it correctly. Okay? The first step is to make sure that the fraction is actually written as a fraction, that you have a numerator divided by a denominator. If you look at example 1, it is not written like that. So how should I rewrite example 1?
Like number 2.
Yeah, make it look like that. So I'm going to say negative 6x plus x to the third over x squared plus x. So that's the first step. It's the rational unit. We want to write it as a rational expression. That means writing it like a fraction. Step 2 says to write the problem in descending order. So what I mean by that is put it in the correct order so that your highest exponent comes first, and then your next highest exponent, and then your next highest exponent, and so on. So if you look at example 1, is it written in the correct order?
No.
No. So how should we fix it?
X to the third is first, plus minus 6x, then over x squared plus x.
Marvelous. So we put it in the correct order. That's step 2. Step 3 is to factor the problem. So we write the problem in factored form over factored form. We want the factored form at the top. We want the factored form at the bottom. So if you look at the top, let me zoom in here. How do you factor that? We have a GCF of x. And when you take out an x, what is left over?
This is
X squared minus 6. Right? And then, now if you look at the top almost looks like that is difference of squares. Is it difference of squares? No. Why not? Because it's a 6. 6 is not a perfect square, so we're going to leave it just like that. We're going to call it good. How about the bottom? How do I factor that? Yeah. So x is a GCF, and then what is left over? X plus 1. X plus 1. So anytime you actually took that number out, you have to leave a 1 as a placeholder. The other way to think of it is you did x squared divided by x was x, and then x divided by x is 1. So you got to leave a 1 there.
Oh, I not what did you do with the negative 6x?
We took an x out of it as a GCF, and that's why negative 6 is all that's left.
Okay. I think you took the negative out of the x to the third, and then
The x to the third did not have a negative.
I mean
An x?
Yeah,
Yeah, we took an x out of x to the third and put it in the front, and that's how we got x squared. Yeah. All right, so we did step 3. We did the factored form and the factored form. Now we reduce things that are in common. So if you think about it, if you had 5 divided by 5, what would you say that equals? 1. If you had x divided by x, what would you say that equals?
1.
If you have x plus 2 divided by x plus 2, what would you say that equals? 1. So anytime you have something divided by itself, you can say that it reduces to be a 1, and once it's a 1, you can kind of ignore it. So when we look at our problem, we have an x divided by x, so I'm going to cross those off. Those make a 1. Right? And then step 5 says simplified form. So that means that I'm at my final answer. X squared minus 6 over x plus 1. That is my simplified form. and I am finished. All right, now excluded values are numbers that you can't plug in for x. They have to be excluded because when you plug them in, they are outside of the domain. That means they are x values that do not work. So if you think about a fraction, what is the thing in fractions that could happen that we don't like to happen? It's top divided by bottom. What can you not divide by? You can divide by negative. You can't divide by 0, right? So if we have top divided by bottom, and we know that we can't divide by 0, then that means the bottom cannot equal 0. Does that make sense? Okay. So what we do to find the excluded values is we take the bottom. So the bottom was x times x plus 1, and we know that the bottom cannot equal 0. Right? X times x plus 1. And I know that those numbers cannot make 0. And then I'm just going to go ahead and solve for that. All right? So I'm going to say this one over here, x cannot equal 0. This one over here, x plus 1 cannot equal 0. So 0 is my first excluded value. I can't plug in a 0 because if I plug in 0, then I get 0 times 0 plus 1, and that zeroes out the whole bottom. And that would be a problem because then you'd be dividing by 0. You can't do that. Okay? How do I solve this equation for x? Minus 1. So x cannot equal minus 1, and that's because in this denominator, negative 1 times negative 1 plus 1 would be negative 1 times 0. Again, it would zero out the whole bottom. So there are two excluded values for this problem. It's 0 and negative 1. So they're saying when you have this simplified expression, you could plug 5 into it. You could plug negative 17 into it. You could plug 5,082,000 into it, but you can't plug 0 in. You can plug 11 in, you can plug 19 in, you can plug in 87, but you can't plug in negative 1. Any number you want except for those two. Does that make sense? Okay, let's try example number 2. So if you look at step 1, it says it has to be written as a numerator over a denominator. Is that true? Yes. It is true. Is it written in descending order? Step 2?
Yeah.
Yes. Okay. Step 3 says to factor. Now, if you look at the definition, the stuff that they say about factoring, they say factor out a negative 1 if the first term is negative. Okay. Where do you see that happening on example number 2?
Wait, no, negative x.
The bottom, yeah, the negative x on the bottom. So we're going to go ahead and start factoring this. We can go ahead and factor the top. What type of factoring is the top? Difference of squares. So we have two sets of parentheses, one with a plus, one with a minus. So we're going to say x and x, right? And then 4 and 4. Okay. And then on the bottom, that's where we can see that we had a negative 1 in the front. Right? We have a negative in the front. So we're going to factor out a negative 1 and then write our leftovers. So negative x divided by negative 1 is positive x. And positive 4 divided by negative 1, negative 4. Okay. Do you guys see any factors that can cancel out and make a 1? Divide by each other to make 1. Yeah, what do you see? X minus 4 and x minus 4. So these make a 1. Okay. So if they make a 1, what's left over? X plus 4 over negative 1. Do you think most people are going to leave their answer like that? No, probably not. What do you think they're going to do? What happens if you divide something by negative 1? Yeah, it makes everything else negative, or if it was negative, it makes it positive, right? So it changes the sign. So if you take a positive x and a positive 4 and you change the sign,
It'd be negative x and negative 4.
so the answer here is negative x minus 4. Now, x plus 4 divided by negative 1 is not wrong. It's just not all the way simplified. Most people are not going to leave a fraction with a 1 on the bottom, whether that one is positive or negative. Most people are just going to write it as a whole number instead.
So pretty much just using that 1 just to get rid of it.
Yeah, we had the negative 1 in the problem because the x was negative to start with. We had to get rid of that negative so we could see if things cancel. Because if you leave it like this, if you have negative x plus 4, it almost seems like it would cancel with the x plus 4, but it's not identical. So that would be kind of like you saying 5 and negative 5 cancel to make 1, right? And you're like, well, they don't quite cancel to make 1. You know what I'm saying? They're not exactly the same. All right, so the excluded values, when we do the excluded values, nobody questioned me on this, but what we did is we went back to the factored form of the bottom. Does anyone know why we went back to the factored form of the bottom? To solve for x? Anybody know? Because that's, if we look at the bottom before, what type of function do we have on the bottom?
A square.
It's a squared. Yeah, what's the name of that function if it has a squared in it? It's a quadratic. And the way that we solve for quadratics is we factor them, right? Okay. So for you to solve the bottom, to see where the bottom equals 0, you have to factor it. Because it's a quadratic, and that's how we do things. If we look over here, this one, the bottom here is not a quadratic, so we don't really have to factor it. But we can go ahead and still use the factored form to find our excluded values. That's going to be the trend. We will always go back to the factored form before we cancel things out. We're going to go back to the factored form and see what the excluded values are. So here, I'm going to say negative 1 times x minus 4 cannot equal 0. That's how I'm going to find my excluded values. Now, this negative 1 does not have an x attached to it, so there is no excluded value being represented here. That is always going to be negative 1, no matter what you plug in for x. So we can ignore that part. I'm just going to look at this part, and I'm going to say x minus 4 cannot equal 0. And then how do I solve for x? Plus 4. So x cannot equal 4. And that's because if it equals 4, we're dividing by 0, that's a problem. Okay? All right. Let's go to the next one. So step 1. It has to look like it's numerator over denominator. Does it look like that?
C.
Yes. Step 2, it has to be in descending order.
No.
No. Okay, so let's rewrite it. Okay. Step 3 says to write it as factored form over factored form. So how do we factor the top?
Do we have to diamond it?
Yeah, so we're looking for what multiplies to negative 5, but adds to negative 4. Negative 5 and 1. So the top is x minus 5 and x plus 1. Okay, and then for the bottom, we're going to say what multiplies to negative 15, but adds to negative 2. Negative 5, and what was the other one? 3? Okay. X minus 5, x plus 3. Okay. Do we see any factors that will divide to be 1?
Yes.
Yes.
The 5s.
The 5s. Okay, those divide to be 1. Okay, so what is our result? What's step 5, our final answer?
X plus 1 over x plus 3.
Mm-hmm.
Okay, so what about the other numbers?
So when you look at this problem, do you guys see how these two things are multiplied together? So here we've got a situation where we have multiplication and then we've got division, and I'm trying to tell you multiplication and division cancel out. Would you agree with that? Okay. Now let's say someone else was like, Miss Rice, I think that x plus 1 over x plus 3 is 1/3. Is that person right or wrong?
Right.
Wait, think about it. Think about it. Is this person right or wrong? They think that x plus 1 over x plus 3, the x's cancel to make a 1, and the answer is 1/3. Are they right or
Maybe
wrong?
1 and 1/3. No.
I don't know.
Think about it. Well, what operation is happening on the top? Plus. Do plus and divide cancel out? No. So this is not possible because plus and divide do not cancel out. Now let's look back at this one. Why did this one work? Because it was multiplication, right? We've got one set of parentheses times another set of parentheses.
Yeah.
It's multiplication canceling with division. So this one works. Why does this one not work? It's addition. You're doing plus and division canceling and those don't work. Does that make sense? Okay. So that's why we have to write it in the factored form, because for us to cancel division, we need to see what things have multiplied together, because multiply and divide cancel. Okay? So I'm going to say, don't do this. Don't do it. No. No. Okay. All right. So now we're going to go back to our factored form. And we're going to look at the bottom, and we're going to find our excluded values. So the bottom said x minus 5 times x plus 3. And we know that the bottom cannot equal 0. So x minus 5 and x plus 3, that was the denominator. That cannot equal 0. So I'm going to find two things from this. I'm going to find that x minus 5 cannot equal 0, and I'm going to find that x plus 3 cannot equal 0. Those are the two things that I see from this problem. So what is my first excluded value? 5. Yep, so I'm going to add the 5 over. X cannot equal 5. And then I'll subtract the 3 over. X cannot equal negative 3. So those are called excluded values because they are outside of the domain. So if somebody said, Ms. Rice, what is the domain for this problem? I would say every single x except for 5 and except for negative 3. I don't know, it sounded like somebody's phone. So the domain for this problem would be every number except for 5 except for negative 3. Okay. Go ahead and take your paper, flip it over to the back side. There's no back. There's nothing on here, but there are a few things I want you to write down. Okay, so a few steps that we're going to remember for this. After this, yes. Is that for this unit, we factor. We have to factor everything. Why do we have to factor everything? Think about what we just said. Think about this part right here. Why do we have to factor everything? We have to see what multiplied because we're canceling division. So we factor because we have to see what was multiplied so we can cancel out division. Okay? So for this unit, factor. If you get stuck on a problem, just factor it. Right, Marquise?
Yes, ma'am.
Make sure you text whoever that they need to factor it. All right. Factor. You can only cancel things that have been multiplied. So that's going to be two sets of parentheses. I'm going to write it like this so we can see that things that have been multiplied can cancel. Does that make sense how I wrote that? You can only cancel things that have been multiplied.
No.
Do not cancel things that have been added or subtracted. So we're going to say do not. I'm going to make this real dark. Do not. Don't do it. Don't do it. All right? Don't do it. Don't do it. Don't do it. Don't do it. Okay. We're going to do one more example. Because if you look at the front had like a binomial divided by a binomial. What do I mean when I say that? Two terms divided by two terms. It had a trinomial divided by a trinomial. What do I mean by that? Three terms divided by three terms. We didn't do any that were monomials. What do you think monomial means? One term. One term. There's no such thing as a quadnomial. After that, they call it a polynomial. Polynomial is like 4 terms, 5 terms, 6 terms, 7 terms, 8 terms, 2 terms, 1 term. Polynomial like defines everything. So for this example, we're going to do 18 x to the third divided by 24 x to the second. 18 x to the third divided by 24 x to the second. So here, there's no plus or minus in the problem. So all the canceling you can do is fair game because there's no plus or minus in the problem. We know that 24 is being multiplied by x squared. 18 is being multiplied by x to the third. Since multiplication is what has happened in this problem, any division we can do is totally fine. Okay? So when you're looking at a monomial and you need to do some canceling, you look at the numbers first. So do you guys see a number that I could divide out of 18 that I could also divide out of 24? 6? Is 6 the biggest number? I can see 3, but 6 would be bigger than that, right? Okay. So 18 divided by 6 is 3, and 24 divided by 6 is 4. Okay. All right. How about x to the third and x squared?
X2.
So I agree that x will be part of our final answer, and I agree that x2 is what we're seeing that could cancel. So what are we ending up with? So I'm going to say there's an x times an x down here, right, that I could cancel out with 2 x's on the top, and that leaves me with how many x's? 1. Okay. So that means that for this monomial, when we're done, we have a 3 left on the top, and we have an x to the 1 left on the top. And then on the bottom, we have a 4 left. All right. How about the excluded value? How do we find the excluded value?
The whole thing?
So you go back, and we go before we canceled things out. So we go back to the problem before we canceled, and we take the bottom, and we say that the bottom cannot equal 0. So 24x squared cannot equal 0. How do I solve that for x? Before we square root. Divide the 24 over, right? So what happens if you do 0 divided by 24? You get 0. So we have x squared cannot equal 0. And then how do you get x alone? Square root it. Okay. So when we square root 0, what do we get? 0. So this excluded value is x cannot equal 0. You can plug in 1. You can plug in 15,047,000. You can plug in negative 832. But you can't plug in 0. Make sense? How are your brains feeling?
It's just what the excluded values are.
The excluded values are kind of weird. So what are we basically doing today? Factor cancel.
Yeah.
Would you agree with that? If we were to sum up today in 2 words, factor cancel. Make sense?
Yeah.
Factor cancel. All right, here we go. All right. What do you guys see on number 1?
45. Oh, a negative.
I see a negative. I see a 45. I see a 90.
A P.
And this is a monomial, right? Okay. So when we look at this, what do you see cancels with the numbers?
45.
Yeah, and I can actually see on this one, I don't even really have to simplify that fraction. I can just straight up divide those numbers. What happens if you do negative 90 divided by 45? Negative 2, yeah. So I'm going to say, all right, that's given me negative 2. What about having p squared over p?
You get P.
You get p. Now, the instructions did not say to find the excluded value, so we can relax our brains for a little bit on that one. All right.
Thank you, God.
Number 3 says, check me. Is number 3 right? Don't say it out loud. Just think about it. So we're just checking it. Do we think it's right? Don't say it out loud. Just think about it. Do we agree with their answer?
No.
No? Yes?
Well, yes.
Okay. So what was their first step? How did they get from here to here? Okay, they divided by 6 on the top and the bottom, right?
Yes.
Okay. And do we agree that 12 divided by 6 is 2?
Yes.
And 54 divided by 6 is 9?
Yep.
Okay, we agree with that. How did they get from here over to here?
They did the M's.
Yeah, they got rid of the m's, right? They divided by m on the top, and that became m to the second. They divided by m on the bottom, and that became a 1. And 9 times 1 just stays 9.
So what would
right?
it go when you do check the N's, right?
Check.
Check.
Okay.
Check it's right. Okay. Go ahead and try number 5 on your own.
He said, shut up. That's got something to say.
Anyone want to give me a hint on how they started it?
I got you.
Divide by, so I heard divide by 6 and I heard divide by 12. Divide by 12? Why would it be better to divide by 12 than divide by 6?
Because it's the greatest.
Because it's the greatest common factor, yeah. So we know that 6 goes into both of them, but we want to do the biggest one. Now, if you divided by 6 first, you're not wrong. You just have to do it again and divide it by 2 the second time. So it just makes it a 2-step process instead of 3. Or instead of 1. So divided by 12, what do I get on top?
1 over 5. 1 over.
And divide by 12, I get 5. Okay. How about the x and the x to the third?
X squared.
X squared?
Yes.
Agreed? Alright, so I take out an x on the top and that leaves me with nothing. Take out an x on the bottom, that leaves me with x squared.
Yes.
We got that?
Right.
Marvelous. Okay.
This is one way.
We're going to hop down to number 9. Why is number 9 a nice problem?
Because the 6's can cancel out.
The 6's can cancel out. What else can cancel out?
I mean,
The x's, yeah. So number 9 is nice because they factored it for you. It is just like ready to go. You don't really have to work that hard. So we can see 6 divided by 6 makes a 1. X divided by x makes a 1. And so what would our final answer be? 3x plus 4 over 5x plus 6. Okay. Go ahead and do number 11. Don't say it out loud. Just do what you can with number 11. See what you can get. Anyone want to tell me what they got that divides to make a 1?
The N.
Say it
The
again.
N.
The n divided by n is 1. What
And
else?
the N and the N on the inside.
So, wait, just the n's?
All
The whole thing. N plus
wow.
1 and n plus 1,
Okay.
yeah? Mm-hmm. Now the n's on the inside, you can't just say n cancels with n. Why not?
You're adding.
So yeah, so think about it. That's why we were saying if you look at this and you say, sorry, eraser. N plus 1 over n plus 1. You can't look at this and say just the n's cancel.
This is the whole thing.
And the reason you can't say that is because n plus 1, that's plus. I can't say plus and division cancel. However, this whole thing divided by that whole thing is the same thing divided by itself. And since it's the same thing divided by itself, it does make a 1. So as long as I think of the whole group divided by the whole group, I'm okay.
So would it just be 8 over 10?
So it would be 8 over 10, except what do you notice about 8 over 10? Yeah, divide the top by 2, divide the bottom by 2, and you get 4 over 5. Marvelous. All right, go ahead and try number 13.
Fun. Oh, you gotta find the excluded values.
Yeah. So make sure you do the simplifying, but you also gotta find those excluded values.
With the helmet. Make sure one. Oh wait.
You said 13, right?
Yep.
I'm assuming that we're going to finish
We always gotta finish the class. I'm not giving you any extra. What do you guys see that divides to make a 1?
N minus 10.
N minus 10, N minus 10. That divides to make a 1. So what is our simplified answer? Did anyone find the excluded values? N cannot equal... Wait, be careful. The 4 is on the top. Does it matter if the top is 0? No. N cannot equal 5. I do agree with that. And, there's another one. N cannot equal 10. So we are looking at what makes the bottom equal 0. The top can equal 0. I'm okay with that. That just makes the whole fraction 0, and that's fine.
I'm gonna make trouble.
All right. Go ahead and flip it over. Now, don't say it out loud. Don't say it out loud. Look at number 15 and see how you feel about that check me problem. Do you agree with them? Do you not agree? Don't say it out loud. Just think about it. Do you agree with them? Do you not agree with them? Don't say it out loud. Just think about it.
Did you know that elimination argument?
What do we think? Did they do it right? No. What's wrong with it? They didn't factor. So they were thinking this subtraction and division can cancel, and that's fine. Does subtraction and division cancel? No. They had to factor. All right, so how do we factor the top? So for the top, we're going to say what multiplies to negative 20, but adds to
-1.
Okay.
Negative 5 and 4.
-5 and 4. Okay, so we've got P minus 5 and P plus 4. How do we factor the bottom?
16.
So what multiplies to 16 but adds to 8? 4 and 4. All right. What do we see that divides to make 1? P plus 4. Now, do I cancel all 3 of them? No. Just 1 and 1. Okay, so that cancels to make a 1 right there. And so what's left over? Mm-hmm.
Why couldn't you just cancel one out below?
You could have.
Do I cancel whichever one you wanted?
Yeah. So what is our, we don't have to say it, but what's our excluded value?
Negative 4.
Negative 4. Negative 4, negative 4, but that's the same thing. So you only have to write it once. Okay. Look at number 17 and compare it with your notes. Number 17, I would argue, is a really easy problem, but you have to think about it. So compare it to your notes. See if you can figure out how they'd want you to do that one. There is not a lot of work required if you can see it.
You're blind.
If you're blind, it's a little bit harder, then we gotta put it in Braille, then you gotta feel it.
I think you just.
Or here.
So when you look at this sheet of notes, what does this sheet of notes tell you to do on number 17?
Tells you to factor out negative 1.
Factor out the negative 1 on the bottom. That's what it tells you to do. So I'm going to leave the top the same. And I'm going to take out a negative 1 on the bottom. And what does that leave me with?
N squared. Minus 13n. Plus 40.
Okay. Now what can we say?
The top,
Mm-hmm.
the bottom.
Yeah, I don't even have to factor it. I can already see the top and the bottom cancel out. They're identical to each other.
Is that 1 over negative 1?
So, and what is 1 divided by negative 1?
Negative 1.
Just negative 1.
0.
Good. That ain't right.
We feel so good talking about all this stuff.
Doesn't it? And to not even have to factor. Just be like, it's the same. Let me just cross it out.
Hold on. What did you do with your n squared?
Now, it's the whole thing. N squared minus 13n plus 40 is one whole group, and that whole group cancels with that one. Okay. All right, so the plan is to work on this and hopefully turn it in before the end of the period so that we bring nothing home for spring break.
I'm not done.
That is the goal. All right?